This screencast is on the Unit 2 test review warm-up. So looking at problem 1, we are going to evaluate the function of f of 4. So what that means is we are taking 4, we're going to take that number, and we are going to plug it in for x. Excuse me. So what's going to happen is we're going to take 3 times 4 plus 2, and then in 4 in parentheses to the second power. So we want to be careful that we do this step here first, because a lot of times people take 2 times 4 and get 8, and then they want to do 8 squared. So 3 times 4 is 12. And then this will give us 2 times 16, which will give us 32. And then when we add them together, we end up with 44. And then that is it. You're just plugging in those numbers in for x. Excuse me. All right, problem 2, we are going to look at our inequality. So this is going back a while. We're going to draw our lines down our inequality symbol, and we want to get x by itself. So we're going to subtract 2 from all 3 parts. So we have 8 is less than x, which is less than or equal to 15. So we have our inequality. We are now going to plot our points. 8 is an open point because it does not have the line underneath. 15 is filled in because it does have the line underneath. It's included. And then we are going to connect between the two of them. So anything 8 up to 15, including the number 15, would be a solution. So the biggest problem or problems that people had with this review were problem 3 and 4. So for problem 3, we're going to go through, and remember, all of these are separate pieces of each other. So sometimes people want to put the 3u to the 4th together. No, they're all separate and they're all being multiplied. So we are going to take our 3 times our 3 to get 9. And then we're looking at our u with to the exponents. So we have u to the 4th and u to the 3rd. So we had talked in class that that is saying u to the 7th. So if you have 4 u's and 3 u's together, they make 7. If we look at our v's, we have v squared and v to the 4th. So that's v to the 6th. On the bottom, we still have the same thing. At this point, we want to combine our like terms or kind of condense it from top to bottom. So we know that we're still going to have the 9. The 9 does not change. So 9 stays put. Our u value, we have 7 on the top and 4 on the bottom. So the shortcut was to subtract them. So 7 minus 4 is 3. With our v's, subtract 6 minus 2, we get 4. So we're left with 9 u to the 3rd, v to the 4th. If you would rather write this out, and this is how we started the class when we did the exponents, you have a 3, a u 4 times, a v 2 times, another 3, u, v, 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 v. On the top, 4 u's on the bottom, and 2 v's on the bottom. So when we started this in unit 1, we had said that, okay, whatever's on the top and the bottom, you can cross out. So I can eliminate from the beginning 4 u's and 2 v's. So now that all is gone. So what's left is a 3 times a 3, which gives us our 9. And then if you look at our u's, we have 3 u's left over, which is the 3. And then we have those 4 v's left over, which is where that 4 is coming from. So you could also do it that way instead. Number 4, again, simplifying. So if we use the shortcut said that we're taking all of this to the 3rd power. So we're going to take 2 to the 3rd. So that's 2 times 2 times 2, which is 8. And then x to the 3rd means that we're going to have x to the 9th, because a power to a power, they get multiplied. And then the z's will be z to the 6th power. On the bottom, I'm going to condense my like terms. So I have x to the 3rd and x to the negative 4th. So because they're being multiplied in the denominator, I'm going to add their exponents, which is x to the negative 1. My y to the 4th is the only y, so that's going to stay put. And then my z's, I have z squared and z cubed, which makes z to the 5th power. So now that we condensed the top part and the bottom part, we want to go and do the top and bottom together. So our 8 is going to stay put. That does not change. So let's look at our x's. We have 9 on top and a negative 1 on the bottom. The shortcut was to say, all right, we're going to take the top minus the bottom. So 9 minus negative 1 becomes a positive 10. That becomes 8x to the 10th. Our y value to the 4th power is going to stay put because we have no other y values to combine it with. And then our z's, we have 6 on the top and 5 on the bottom. 6 minus 5 is 1. So we'll have z to the 1 power, or just z. So we're taking our exponents and we are condensing it. Excuse me. All right, problem 5. We're looking for the range. Remember, range is y value. So in class, I had mentioned that it might be helpful when you have a picture like this to see what numbers are connected to that, to those points on the y-axis. And then we're just going to make a list. And it does not have to be in numerical order. It could be random, as long as you have the correct numbers. So we're going to have some combination. I can shrink that a little bit more. There we go. Of 4, 1, -1, -2, and -3. Again, looking at the y values only. For domain, we're looking at x's. So we're only looking at those x values. So we have 10, we have 14, and we have 8. Turning to the next page, we want to find the slope and y-intercept of our equation. So remember our equation y equals mx plus b. M is the slope. If we look in front of our x, we don't see a number, but we do have an x. So we can't say it's 0 because that would be there would be no x then. So if we have an x but do not see a number, it is always a 1. Our y-intercept is what's added or subtracted at the end. If that is missing, that will be 0. So we're going to move into our sequences. So problem 8, we want to see, is it arithmetic, geometric, both, or neither? So we talked in class, if it is the same number repeated every single time, this is a both sequence, because you could add 1 each time and it would work out. You could also multiply, I'm sorry, not add 1, add 0. That wouldn't make sense. Add 0 each time. Get myself confused here with my words. And then the other choice would be to multiply by 1 each time. So if it's the same number every single time, it is a both sequence. All right, problem 2. Taking a look at first glance, you may say that it is arithmetic, that we're increasing each time by 1. But when we go from 3 to 5, that is an increase of 2. So this problem 9 is going to be an example of neither. It's not arithmetic because it's not adding or subtracting the same number every single time. And it's not geometric. You're not multiplying or dividing the same number every single time. All right, problem 10. A line has a slope of 3, passes through the point 1, 3. What is the equation? So right away, we know slope is 3. So you should automatically say y equals 3x plus, and then we're going to have this missing piece. So setting up what we know, our x, our y, and our m, we're going to take that and we're going to substitute those pieces in. So we have 3, because that's our y, equals 3, which is our m, times 1, which is our x, plus b. Multiplying 3 times 1 together just gives us 3. So we have 3 equals 3 plus b. So if I subtract 3 from both sides, my b becomes 0. So you could leave it like this, or you could drop that all together and just say y equals 3x. or 3x plus 0. All right, problem 11. We want to find the line that passes through the points. So first thing, we have to find our slope. So slope is change in y over change in x. So we're going to take negative 11 minus 4 over 3 minus 18. So you can plug that in your calculator if you want to altogether, or you could work it out. Either way, you should get a slope of positive 1. So right now, I know my equation is y equals 1x plus something. So to find out what that something is, just like what we did in problem 10, we're going to pick a point. I'm going to pick the second point here. And I'm going to replace that in my y equals mx plus b. So my y is my 4, my m is 1, and my x is 18 plus b. 1 and 18 make 18. So I have 4 equals 18 plus b. And I'm going to subtract 18 on both sides. So I end up with negative 14 equals b. So up here, I'm going to plug that piece in. Remember, it is a great idea to check your equations to make sure they work out. So what you can do is you can take that 3 and plug it in. 1 times 3 is 3. 3 plus negative 14 gives you negative 11. So that's going to work out. Moving on to problem 12, we are given a table. We want to find out what is our equation. So looking right away, we can see that we're increasing each time by 3. So that's going to be our slope. Now, working backwards, we need to find the y-intercept. So I'm adding a 2, a 1, and a 0 to my table. So if I know I'm increasing each time by 3, if I want to work backwards, I'm going to subtract 3. So 7 minus 3 gives me 4. 4 minus 3 is 1. And 1 minus 3 is negative 2. Well, that is going to be my y-intercept. Again, you could check. If you take, let's say you take 6 and you plug that in for x, 3 times 6 is 18. 18 minus 2 gives us 16. So it's going to work out. Problem 13, we want to find our x and our y-intercept. So to find the x-intercept, we are replacing our y value with a 0. So anything times 0 is 0, so that's gone. So we have 2x equals 4. And then we want to solve for x. So we're going to divide both sides by 2. So we end up with an x-intercept of 2. To find the y-intercept, we are going to replace our x with a 0, and we want to solve for y. So anything times 0 is 0. So we know right now that this is nothing. Ooh. So we have negative 7y equals 4. So be careful. We want to divide both sides by negative 7 because our y and our negative 7 are being multiplied. And I'm just going to leave it just like that. If you wanted to, you can convert it to a decimal, but you can leave it as a fraction. So that would be our y-intercept. So to find the x-intercept, notice that you plug 0 in for y. And to find the y-intercept, you're plugging 0 in for x. So you're plugging it in for the other letter. And then number 14, we want to find our equation. So looking at 2 of our points, we can figure out we're going down 2 and over 3 blocks. So that will be y equals negative 2 over 3x. And then to find that y-intercept, we're looking to see where on this y-axis is our line crossing. And you can see it's at the number 4. So we have plus